Okay, so we continue with our discussion of how to evaluate limits by recalling a formula you might have seen for the difference of positive integer powers. Okay, so you will have heard of the difference of squares formula, two real numbers a and b, a squared minus b squared is equal to a minus b times a plus b. If we look at the difference of cubes, then a cubed minus b cubed looks like a minus b times a squared plus ab plus b squared. Okay, and in general, for n a positive integer, a to the n minus b to the n is equal to a minus b times a n minus 1. Now reduce the power of a to the n minus 2, increase the power of b from 0 to 1, plus a to the reduce the power of a to n minus 3, increase the power of b to b squared, and so on up to a to the b to the a times b to the n minus 2 plus b to the n minus 1. Okay, so we're going to make use of that formula to do certain kinds of limits. Okay, so let's say that I want to evaluate the limit as x goes to b of x minus b over x cubed minus b cubed. You can't just put in x is equal to b, because then we would get division by 0. And so when you end up with division by 0, you want to look around and see what you might be able to do. If there's some algebraic manipulation that you might be able to do, that will help you out. And so we try the difference of cubes formula. Okay, and we get that the limit as x goes to b of x minus b over x cubed minus b cubed is equal to the limit as x goes to b of x minus b divided by x minus b times x squared plus xb plus b squared. So for the denominator, we have used the difference of cubes formula. Okay, now we've got an x minus b in the numerator and an x minus b in the denominator. We can cancel them. One thing you should take care of when you're canceling is you're not canceling by 0. But when we say x goes to b, we mean that x gets arbitrarily close to b without ever being equal to b. So that means that x minus b is not 0. So we cancel the x minus b on the top and the bottom, and we're left with limit as x goes to b of 1 over x squared plus xb plus b squared. We'll discuss a little bit about why then you can just substitute in the b, right? So x squared plus xb plus b squared, as x goes to b, x squared goes to b squared, xb goes to b squared goes to b squared. So we've got 1 over b squared 3 times, or 1 over 3b squared. Okay, so that's one example of where using the difference of positive integer powers formula allows you to do a simplification, which then allows you to do the limit. Okay. Okay, well, now let's try limit as x goes to b of x minus b over x to the n minus b to the n. Once again, you can't just put in x is equal to b. You would be dividing 0 by 0, right? But you can use the integer powers formula, difference of integer powers, and you'll get that this is equal to the limit as x goes to b. On the top, you still have x minus b. On the bottom, you've factored out an x minus b. And the second factor is x to the n minus 1 plus x to the n minus 2b, and so on up to b to the n minus 1. Now, letting x equal b won't cause any problems. You have a polynomial on the bottom, and the polynomials are nice functions. They're examples of functions that are continuous everywhere. You can evaluate the limit of a polynomial just by taking the function value. So you get 1 over b to the n minus 1 plus b to the n minus 2b, and so on up to b to the n minus 1. There, you will see that each of the summands in the denominator is actually b to the n minus 1, and there are n of them, so you will get 1 over n b to the n minus 1. All right, so that's one more technique that you have in your toolbox now, which is for evaluating uh, limits.